consecutive term from 2020 to 2023 for all the 5 engineering disciplines. VVCE got autonomous status from the academic year 2020 onwards. The Department of Civil Engineering was incepted in the year 2013 with an intake of 60. 3 batches have rolled out of VVCE. We are proud to share that the student of 3rd batch has secured 10th rank in the VTU examinations for the academic year 2018-19. The NBA team has visited our department in February 2020 for the first time, and we are waiting for the results, and it will be out in a day or two. We are organizing 4 webinars in this series, today being the 2nd webinar on sustainable global energy transition in collaboration with National Institute of Energy, Chennai. I request the participants to kindly join us for all the remaining 3 webinars for enrichment of knowledge. Now I feel it is my bounded duty to accord welcome to all of you. At the very outset, I wholeheartedly and immensely welcome the renowned resource person, Dr. S. GOMATHINAYAGAM, former Director General, National Institute of Wind Energy, Chennai. I welcome you, sir.
Thank you. I'm not seeing your video, sir. Okay.
Secondly, I sincerely welcome all the participants, teaching fraternity, invitees, and my dear student community.
Thank you very much, sir. We welcome. Dr. Umesha P.
Good morning to everyone. It's a great pleasure to me to introduce our speaker, Dr. S. GOMATHINAYAGAM, former Director General of National Institute of Wind Energy, Chennai. He has graduated from Regional Engineering College, NIT, Tirunelveli. Now it is called NIT. He has got his MS and PhD degrees from IIT Madras. Afterwards, he has served as the Deputy Director in CSIR, Structural Engineering Research Center, which is one of the national laboratory under CSIR. He is involved in many projects related to space, navy, offshore, energy, railways, telecommunication, wind tunnel, wind and solar power. Afterwards, he joined as a Director General in National Institute of Wind Energy, that is coming under Ministry of New and Renewable Energy. So he has done several first in NIWE under MNRE, demonstrate the initiative as a leader towards the positive developments useful to industry, wind and solar resources, National Data Network, and Indian Atlas release. Established a real-time operational wind power forecasting and scheduling. He is responsible in making the institute as a self-sustaining institute. He is now serving as an independent consultant, and to tell, he has received many honors and awards. Naming a few, he has received a Lifetime Achievement Award for outstanding contribution in the field of renewable energy by the Institution of Engineers during October 2017. He has received a KCG Varghese Lifetime Achievement Award in 2017 for the outstanding contribution in the field of wind energy research and society. And also he has received Lifetime Achievement Award for extraordinary contribution in wind energy research and institutional capability building by Savita University. He is also received Eminent Scientist Award by former High Court Judge, that is Government of India, at Bharati Vidya Bhavan during 2016. He has also received Distinguished Alumnus Award for Excellence in Scientific and Industrial Research at Golden Jubilee at NIT Tirchi, in the presence of His Excellency, Honorable President of India, Dr. Pranab Mukherjee. He also received Global Excellence in Renewable Energy during 2013 for vision, leadership, outstanding contribution, and demonstrating excellence in the renewable energy sector by Honorable Minister Oscar Fernandez. He is a fellow of Institution of Engineers. Also, he is a life member of and chartered engineer of Institute of Engineers. He is also a life member of Computer Society of India, Instrument Society of India, Indian Society of Wind Engineering, Indian Meteorological Society. He also received DAD, UNDP, and Australian Aid Fellowships. Now, today, we have such an eminent person with us to talk about sustainable global energy transition on webinar arranged by Vivek Vidyavardhaka College of Engineering. Now, I request Dr. Gomathinayagam to take over and start the session. Dr. Gomathinayagam, please.
Thank you, Mesha, for a very high profile introduction. I'm a simple scientist. You know, okay. Thank you very much.
Okay.
Shall I start now?
Yeah, please.
Okay. Thank you. Good morning, everyone. We are amidst Corona lockdown. We are able to be here with me for a brief time to know what is sustainable global energy transition. It's more of an awareness program. It is highly multidisciplinary. It will be giving you an overview of the world. What we are living is borrowed from our kids and our grandkids, not inherited from our forefathers. This you have to just keep it in mind. Since it is borrowed, we have to give back to our children and their children the world as it is, without big pollution. That is the purpose of this lecture. Sustainable global energy transition. So let me just highlight briefly what all things can be done. Rooftop solar, big wind turbines. You can imagine thousands of this kind of small wind turbines operating all over the world, even though there is no standardization. But it is possible. If there is a will, there is a way. We can get excellent energy conservation, energy optimization in our lifetime to give the world to our kids and their kids. So let me quickly go through one by one. Sorry if we cannot interact in between with all the audience. The profile of today's lecture will be basics of climate change mitigation, emission sources and reduction. And we'll talk about renewable energy, world and Indian scenario. We'll talk about solar power technology. All of you know Karnataka was pioneer in mandating rooftop solar for getting building approval. I think they had the best renewable policy in India for the first time. And wind power technological advancements, onshore, offshore. We'll cover briefly an overview of some existing small hydro, small scale rural biomass applications, and renewable energy management, smart mix of renewable energy, how we can turn waste, and transport fuel should be still burn diesel and petrol. Global energy transition roadmap and the way forward in future. So let's move on to the first slide. The corona effect is temporary, all of you know. So the growing energy demand, this is an energy demand for heat as well as electricity and every other thing what you are using, cooling, heating, everything you need energy. transporting, logistic movements, everything. This is ton equivalents of energy, what you are seeing here. And the important point here is 70% of the energy demand will come between 1971 to 2030. 70% of this demand, increased demand, will come from developing countries like India. And growing energy demand, sector-wise, if you see, you have the lowest is the transport sector, but it will keep on increasing, and power sector, and industrial sector, and other sectors. This energy, not only electricity, everything, all inclusive, heating, cooling, cooking, everything. Then we have this greenhouse emission problem. I don't want to go into the detail. Emission sources, I want you to realize. So I have listed the fossil fuels, electricity usage, because still we are using electricity from coal-fired and fossil fuel-fired, more than 50%. That is why electricity usage also, CO2 emission will be there. Transport sector, industries, commerce, agriculture, forestry, livestock, animals, land use, community waste. And just remember, the CO2 left by your grandfather is still remaining in the air, because the half-life of CO2 is 120 to 150 years. So what we live, will live even after our death. Okay? So we have to leave emission as low as possible. What are the sources of emission? See the percentage of the sources of emission. You have electricity and heating, a major contributor, 24.6% emission. It's an excellent book by Soli Arcivella, who was a world-renowned person, Green Technologies for a Better Future, in which it's vividly covered how we can have green technologies. Deforestation also adds to electrification emission, and transportation, obviously 14.5%, industry and agriculture, because the paddy fields what we have, they release methane. It's also one of the emission gases. Then other fuel burning and fugitive emissions and waste burning and so on. Okay, if you look at the transportation sector, the Europe has used this EC policy framework to propagate how mobility should be changed over the years. First, enable a mix of policy and measures, and next, avoid unnecessary journeys, public transport, and that will be less polluting. Also, improve everything, efficiency of the vehicle, efficiency of transportation, and efficiency of low emission. And we'll just look at some emission factors of fossil fuels. There is a big lignite has got the highest CO2 emission per megawatt of the power in tons, 1.3 tons per megawatt of power from lignite power plants. Coal 1.05 and so on. So even if you burn wood, it will give you 0.17 CO2 per kg burnt wood. Then we have how we can reduce emissions. If you drive a two-wheeler, 45 gram per kilometer of CO2, 45 grams of CO2 per kilometer you ride in a two-wheeler, three-wheeler 57, trucks 166, go by flight it is 170 to 175. Best is to go public transportation by train, metro rails and other things that will give a lower emission level. And again, you have industries, electricity, usage of electricity gives you almost 0.37 to 0.48 kg per kilowatt hour. For every unit you are putting in the atmosphere 0.37 to 0.48 kg of CO2. And again, industries, Mumbai in UK have 1 ton of CO2 emission because it's a developed country per person per year. It is not very common in a high income group bomb flats. It is about 1.4 tons. It is much more than you. And in terms, it is 0.05. Then we have the agricultural soils, bagasse, crop residuals. Everything gives a lot of emission levels. Burning human body, 50 kg of CO2 is done, but it is called carbon neutral because the wood would have consumed amount of CO2 to produce. When the plants are growing, they consume CO2 from the atmosphere and light from the sunlight. So human body burning is supposed to be neutral. Okay, this is just to give you what are the emission factors. For a tall building like a 31-story building, they have analyzed as a case study in this book. It gives you almost 738 tons of CO2 per year with only 31 floors, average electricity, AC flats, LPG usage, car travel from common items. All this, if you multiply, you can estimate how much carbon dioxide will be put by a tall building if you use all these facilities. That means we are enjoying a lot, right? Corona effect is temporary. They say the pollution levels have come down by almost 20-year low today. That is, from here, it has come down to this 2000-year level as of now because of lower industrial activity, lower transportation, and other things. But this curve, which is exponential, will immediately pick up after the lockdown scenario. If it is uncontrolled, it will go exponentially. The emissions will be uncontrolled. The parts per million in the atmosphere will also go uncontrolled. So the other curves are, if you take the solid ones, we take some early decision to limit the parts per million in the atmosphere, then what are the scenario? So we need to follow this scenario, avoid this business as usual emission levels in the atmosphere. Okay, luckily, India, being a developed country, uses very low electricity per capita consumption. So India, when compared to the world, it is 1/3 of the world average. In India, per capita electricity is about 1,000 and odd, 1,170. Per capita CO2 also is lower when compared to the world average. And per capita energy in ton equal, because it is still a developing country. We are yet to provide 35% of our people 24/7 power. There are almost most villages are electrified, maybe only 1 or 2 lights or a couple of houses. It is not enough. 24/7 electricity should be there for all the people. Then we have in commercial energy demand, India is on the upswing because it's a developing country, having a lot of industries growing day by day. And growing electricity demand is also with a lot of challenges. A lot of electricity demand is growing. It's a highly populated country. We are importing 80% of the oil what we are using, fossil fuels. Even some coal is being imported, some percentage. And India is yet to achieve that universal electricity access for everyone. Okay. Now look at the fuels which will give you energy. Oil may last in 2020. This is a old slide. In 2020, oil may last for 20 years unless they find new oil fields. And natural gases may maybe 39 years. And uranium, nuclear, maybe for 48 years. But of course, coal stays, luckily, as of now. That means pollution stays. So we should avoid the pollution, keep the coal for very essential usage. And all we can see from the previous slides is we have a bright future for renewables. You see the scenario here, 2010, 2016, in that decade. This is the scenario of the renewables. Coal is this much. If we go to 2017 and 2040, scenario is going to be, coal is going to be going down in the energy, and the renewables, especially the solar, is going to be a dominant one, and next is wind, and other renewables are going to take off. So there's a bright future for renewables. It's a highly multidisciplinary area. As engineers and scientists, we will have employability and excellent opportunity, and also inclusive development in even rural areas with renewables. And this is our ambitious target set by the new government. About 175 gigawatts by 2022 has to be reached. We are almost halfway through. Almost 87 gigawatts of renewables are installed in India now. See, this is the 87 gigawatts, what you are seeing here, 87,000 megawatts. It is solar, wind, everything is given. This is available from MNRE's website. And it is March, as on March 2020. So we have been doing path-breaking journey in the renewable space all over the world, not only in India. In the last 4 years, as a tremendous growth, compounded annual average growth of almost 15 to 20% in this sector. Rooftops, hydro hybrids, wind solar hybrids, large wind farms, nuclear reactors, and highly focused concentrated solar power into solar mills, floating solar plants, and biomass plants, and so on. So achievements so far, we have almost renewable energy capacity is more than doubled. Now, 2014 we were about 35,000 megawatt. Now it is 87,000 megawatt today. I showed you in the previous slide. So it is 32,000 solar we have now, 32,000 megawatts of solar, and it is growing day by day. Over 100 billion units of electricity has been generated from renewables and used in day-to-day life. We have gradually moved from 1.5% of energy penetration, not the installed capacity, energy penetration level. Now, 2019, we reached 10%. We have already crossed 10% of energy from renewables in our energy mix, especially electricity. Then off-grid solar applications are increasing. More than 25 lakh solar pumps and several solar street lights, home lighting systems, and these are keeps on increasing. DC homes where the grid is not able to penetrate, they give solar DC homes. They have also been increased to 16 lakhs as of now. Solar lamps about 25 lakhs, solar street lights 6.2 lakhs, and this is a slightly older figure. Now it will be much more. The cost of solar is coming down day by day. So from 17.91 rupees when we started in 2010 per unit of electricity from solar, it is about 18 rupees in 2010. But today it has come down to almost 2.43. This 44 is old. 41 or 43 rupees per unit of electricity. There are several reasons. The government push and several big solar parks have come up, and because the operating cost, the fuel is free. Sun is shining 300 days in a year in India. In one of the recently attended webinars, Indo-German Energy Forum Director Tobias Winter said, in India, 365 days, somewhere or there will be sunshine. It is a golden opportunity for India to go solar in every aspect. Okay, yes, solar budget. Only 2% of the solar energy makes the entire wind power in India. Do you believe that? Because the 2% of the solar energy absorbed in, differentially absorbed in and land surface, that only causes the air to move from place to place. That is our wind power. So tremendous solar energy is there. We are yet to use most of it. Most of them get reflected and goes back to atmosphere. And the measurement of solar energy, accurate measurement has been done by NIWE during my time. National Solar Atlas has been released with the accurate measurement of direct normal irradiation, that is what is coming directly from sun, global horizontal irradiation, what is reflected from clouds as well as normal radiation together, then diffused horizontal irradiation that comes from the reflected surfaces, some diffused light, even though the direct light is not there. That kind of lights also we have energy. So this kind of measurement stations, each one costing about 36 lakhs, was established, 114 stations all over India, and we released a well-validated solar map for India. Now it is available in your mobile, in your hand. You can click SW Urja mobile, you can download, and you can have all the information, wind potential, solar potential, anywhere in India. This is released by NIWE, National Institute of Wind Energy, Chennai. Okay, now let's briefly look at the technologies. Even though many of you know, solar photovoltaic, this develops electricity from sunlight, not sun's heat. So a solar farm in Rajasthan or Tamil Nadu will be very less efficient than a solar PV plant in Ladakh, because solar cell is an electronic PN junction. It will work better in low temperature areas where bright light without pollution is coming to the earth. That will be possible in dry desert like Ladakh, where temperatures are in minus all the time. So this important point you have to know. Solar photovoltaic is energy, the light energy only is used to produce electricity. And solar thermal, we have plenty. We have a lot of heat. We are a tropical country. Bangalore was, I think, first city to mandate heat solar panel to heat water mandatory for building approvals. Okay. What other things you can do with solar thermal? You can make a parabolic reflector concentrated on a single pipe, which will carry a fluid which will take the thermal, and that can be 350 degree to 550 degree centigrade heated steam can come into this fluid. And if you go further, concentrated solar, you can use molten salt as a carrier for thermal solar energy, and you can go up to 600 to 1200 degrees centigrade. A mini solar thermal plant will have several things. You can generate power, use it for desalination, you can use it, or even Mahendra Pune factory has got a 40-ton air conditioner without using electricity, only using solar thermal. This is how it works. There is a receiver, direct beam is focused on here, and the solar heat is used for either electricity or steam, and it can also be used with the thermal storage bins. So with solar thermal, heat only is possible for drying, industrial drying of coal, so that better efficiencies are got in the thermal plants. Then power only you can generate. You can have combined heat and power also with this. So what we have seen earlier is not only conceptual, these are all exist. This is a solar powered air conditioning system. This is a desalination plant with electric power also being generated with the solar thermal, Coimbatore, KG Industries. Tamil Nadu Agriculture University in Coimbatore has got the girls' hostel fully powered by solar thermal. by concentrating the solar thermal and using it for electricity. The rooftop solar, even though it is the costs are coming down, it is yet to go in a big way. The target set for India was somewhere around 40 gigawatts to be reached by 2022. But we are unable to meet the target. It's only 5.7 gigawatts installed so far, and that too mostly industrial and government sector by mandate compulsory they have put that, and then commercial establishments for want of power charges, reduce the power charges, they have put that. Residential is only 12 now. This has to be boosted because residential has got the biggest advantage, and you can also use with the battery. The earlier slide we have seen the cost of solar electricity was almost 2.4 to 2.43 rupees. If you use a very efficient battery with lithium ion and so on, it will only increase the cost by 4.5 to 5.7, whereas our electricity charges are much more than that. So every person who can afford a free shade-free area on the roof, they can definitely make use of solar power in this country. So you have the solar panels, inverter, either you use it in-house or export it to the grid. This is the system, solar rooftop system. So you see this, I don't know whether you are able to see the flow of the electricity. If it is exported to the grid, you get paid at a nominal rate. And if you are using yourself, you are saving the bill of electricity charges as mandated by you to be paid by your electricity board. So better when the sun is shining, use your washing machine, use your motor and so on, so that when the sun is not shining, you can take the grid power. That is on-grid applications. And you can combine off-grid application. This is a solar mill manufactured in India, in Hyderabad, Secunderabad, by a Windstream Inc. US company. And this has got 200 watts windmills, 6 of them, and 1.8 kilowatt of solar panels. Together, this can be about 3 kilowatt solar panel, which is on the rooftop of National Institute of Wind Energy. A German minister who visited was visiting at the places. So instead of diesel genset, you can very easily replace with a battery bank or local wind generation. Showed you in the initial slide, the small wind generators can work even in urban winds. That is, the buildings make air to flow around the building, right? Even those winds you can exploit in the urban area. Standalone, off-grid or plus storage. Without storage, we have seen the previous slide. Charge controller is what is required. If you only want to use DC load, DC TV, DC powered fan, brushless fan, and modern DC homes are plenty of DC homes are installed in India, in the border areas and Rajasthan, Gujarat, and those areas, powered by DC systems. Or you can use an inverter, convert it to a AC load and use it. You can combine along with solar panels, a DG set or a power bank these days, battery power bank, or even your electric vehicle if you are buying, even that can be used to power your home in the night if you have enough ample extra battery storage in the vehicle. The cost reduction of so I have another 20 minutes time, I think. So let me go through. Cost reduction of commercial scale up rooftop solar. The solar modules about 28 to 30,000, inverters 8,000 to 10,000 depending on quality, and it is about 50,000 to 60,000 per unit, that is per kilowatt, and that will come down if there is a mass deployment. Say, let us say 250 kilowatts is deployed in a community or a rural village, then the cost can come down almost by one half. So there is a cost reduction when you have mass application of rooftop solar per kilowatt. Okay. And there is also a recent concept which is given by the recent webinar I attended on 26th by Dr. Rahul Padwekar. He is the president of the Indian Solar Energy Storage Alliance. He promotes battery storage for e-vehicles and also home domestic solar power plants. So they are trying, it's called micro project, microgrid initiative for campus and rural opportunities. It is a multi-institutional project which they are working. Almost it will give more energy, 30 to 50% within 3 years. The cost of electricity from microgrids will come, and it will be more easy to reduce pollution and lower our coal in thermal plants. Just look at quickly the concepts of wind energy. This is on the right side. What you see is a Gaja cyclone. That is not the energy what we can extract with any of the windmills today. In most of the cyclones, what you have seen, small or big, they have to resist the cyclone and stay safe without operating. And if you measure the time history in time, and if you have an averaging time which is 1 hour, let us say the blue window, or 3 seconds, the 3-second average will be V average, that will be 3-second gust wind, we call it. That's a peak, one of the peak winds. If your averaging time increases, it will become average wind, that is hourly wind speed. So for dynamically excited structures, we use gust wind to design the structure. For normal civil structures, we use mean hourly wind to design the structures. And what you see on wind wave and the cup anemometer. This is the direction and this wind velocity measurement. Okay, what you see on the animation is only 3 concepts are there. 7 years vertical axis wind turbine. It is like a broken cylinder in the form of a clover in fan form. In plates bent in curved shape, they are rotating in a vertical axis. This is Darius type. There's an aerofoil kind of blade which is rotating when the wind comes from any direction. This is the most popular megawatt class wind turbines, horizontal axis wind turbine, which has upwind rotation. Lift generated on aerofoil blades. We'll go to that soon. And any measurement of wind to make the potential in the site should be minimum 1 hour, because 1 hour to 10-minute average, the variation is little, whereas 3-second average will be a gust wind. Okay, and this graph on the left side shows as averaging time increases, the ratio of gust wind to mean hourly wind will keep on reducing from a factor of 1.6 to almost 0. 1, okay, not 0. So here on the left hand side, all of you know how the aircraft takes off from the runway. So it picks up a very high speed, and a lift force is generated, what you see here on the aerofoil, the wing, and that is so much lift force because of the high speed 250 meter per second wind speed is generated by burning fuel, gasoline. That is why you are able to lift the aircraft and keep flying. Whereas in windmill, the same concept of lift has to be produced perpendicular to the direction of the wind, perpendicular to the aerofoil, so that this lift force and the lever arm here to the axis gives you the torque at the center. And if you optimize the lift, you are able to generate more power at the center. This is a principle in general, a simple principle how a wind turbine works. But only thing is, not like aircraft, we have to extract energy from thin air, 3 meter per second to 25 meter per second wind. Cyclone wind cannot be extracted for energy. Okay, imagine if there is a windmill here and velocity is coming V1 here. Let's say V1 from this side. Windmill is here, V1 is coming from here. After the windmill, if the velocity is 0, that means you would have captured all the energy from the wind, right? Which is not in the natural flow. So there is a limit of efficiency that's called 0.52 is the Betz limit. Practical wind turbines achieve an efficiency of about 0.4, 40% efficiency of energy captured from the wind. So wind velocity versus power in the wind turbine, power generated by the wind turbine is called power curve. By designing different sizes of the blades and tower heights, one can design the power in the wind turbine, and this is called characteristic power capacity of the wind turbine. But wind is natural. Wind speed is distributed in a frequency. That is 5 to 6 meter per second occurs most of the year, whereas 15 to 20 meter per second occurs only a few hours of the year. So this wind speed distribution and that wind speed, what is the power from this curve, has to be integrated to get what is known as annual energy production from wind power machine. It is clear in a simple way. You have to use a human design power curve of the wind turbine and use the natural frequency, wind speed frequency distribution at the site, specific site where the wind turbine is going to be there, and get the energy transformation. And you have a lot of opportunities in technology. We have pre-stressed concrete, hybrid steel and concrete towers. Only this part is steel. We have built in India 270 meter tall chimneys. Why not build a concrete wind turbine towers even in forest areas? Because you don't need to cut the trees to take jelly and sand to any point in the forest and then build up a tower and then use a small segment of steel to erect the final wind turbine. And this can again be pre-stressed concrete tower, circumferentially pre-stressed, longitudinally pre-tension, post-tension concrete tower can be used. These are all existing in the world, not myth in the thesis or reports. Then we have the offshore wind energy that is picking up in a big way. In Europe, US and UK, it's slowly moving to offshore, because in UK, land-based wind turbine power is costlier than offshore wind turbine power, because land is so scarce in UK. So they use more than almost 5,000 megawatts of installed capacity of windmills located in offshore in UK. Going to migrate to offshore. The studies have been done in Gujarat and in Tamil Nadu, potential sites. This is part of a visit we undertook to an offshore wind farm, European Union delegation. And offshore wind turbine, slightly different when compared to onshore wind turbine. The onshore wind turbine, the cost of the wind turbine, the equipment, wind turbine, the onshore, it is 35% of the total project cost. Whereas in the offshore wind turbine, the cost of the EPC, the piles, supporting structures, erection, commissioning costs of these wind turbines in very troubled atmospheric weather conditions, these are almost 65%. 35% is the cost of the machine, wind turbine. So that's completely ulta, or reverse in the case of offshore wind turbines. So in the case of offshore wind turbines, if there is a mass gigawatt power plant, then cost will be more enable and it will be viable. Okay, what is the size of the wind turbine you can think of today? The latest announcement by Siemens Gamesa after their merger with Gamesa is a 14 megawatt in one single windmill, about 222 meter diameter of the rotor. One blade is about 111 meters. So you can imagine the gigantic sizes. It cannot be definitely taken through our Indian roads. That is the reason offshore manufacturing should be happening close to the coast and put it on the barge straight away, go to the site and install and commission. And these are things not going to happen in our time. It's going to happen in our time in India. India is pushing very fast for that. This is again a closer look of a blade which is 107 meters produced recently, and the towers for that, supporting towers, are transported and erected. It's a hybrid tower with steel and concrete, steel cylinder there. Tower heights are slowly increasing. They are predicting 10 gigawatt, 12 gigawatt and 14 gigawatts we have already reached now. This is going to be commercial market in 2025-24 soon. So we go through some of the slides on small hydro. A typical arrangement of small hydro. There is a tank at a higher elevation or a dam at a higher elevation. It's a steep slope. Then you put your generator, use a penstock pipeline or the flowing water. You can produce a small electricity. This is in Uttarakhand. Also in canals which are flowing very fast, when they are releasing the shutter, there's a good speed that can also be used in Punjab. This is a small hydro. Dam toe, when at the toe there's a gushing of water when the shutter is released or when it falls down on top. The extra high speed of the water flow can also be used. This is in Madhya Pradesh. Then biogas for cooking is not new. I think Karnataka is doing excellent work. There's a demonstrative biomass, I think somewhere in Bangalore, very close to that. I forgot, I have visited. Now there are 2.5 lakh biogas plants set up in the last 4 years. And solid waste dump stinks. Why does it stink? That is 0.42 grams per person per day is a normal waste release. And 10 lakh people almost release 420 kg per day and 153 tons per year from the 10 lakh people. Methane, which is getting generated in these dump yards, just gets to the atmosphere. That is why it stinks. If you capture this through bored pipes and suck it through the pipes and store it in containers, methane can be a fuel, excellent fuel, waste to energy. And renewable energy has generated excellent employment in rural sector. And Many people say when the sun is not there or when the wind is not there, you cannot have the power. Renewable energy forecasting has been in a very highly matured level. Day ahead forecasting can be given with excellent accuracy and within 5% accuracy, so that the thermal plants can be very well managed along with the renewable penetration. In India, Tamil Nadu has got the highest penetration of renewable energy. Almost 35 to 40% of the energy comes from, especially in the month of windy months of May to September, both solar energy as well as wind energy together, almost 35% of the used electricity in Tamil Nadu. That's become possible because of the excellent accuracy of forecasting. Inter-day forecast, day ahead forecast in the night, previous night at 7 p.m. Week, this will be less accurate, and seasonal forecast, this will also be less accurate. This day ahead and inter-day forecast can be quite accurate, and you can very well manage the hydro generation as well as thermal generation. In smart buildings, we will have home energy managers, automatic switching off of AC, solar photovoltaic of 3 kilowatt to 4 kilowatt is enough to power many of those controls which you will be using in your house. And very important thing is, where you produce electricity, there is no transmission and line losses. And if you don't use electricity, then you can very easily if you don't use electricity, you can very easily give it to the grid so that others can use it. Then geothermal energy, if you dig into the earth, there is a lot of heat energy after some depth. This is not available in every point, and you can send the water to that level, and the steam can be generated, and that steam can be used for house heating, as well as you can use it for power production. Waste heat also can be converted into electricity. Industrial waste heat can be converted to electricity by recovering the heat with thermoelectrics. Tidal power plants, I am showing what is available in the world. India does not have many. It requires a specific geographical location and good tidal height. As the high tide comes, the water comes into this dam, and when the low tide comes, when the water is shut down, this can generate power when the high tide enters, as well as when the low tide water goes out. Okay. On location in Gulf of Kutch, there's a potential. It's being studied quite so many years by several national institutions, but it is yet to come into a reality. Okay, methane is also getting released from paddy fields, because we have the methane emission from dump yards, the landfill biogas we call it, and this can be filtered using simple suctions, and this can be used for pipelined gas, methane gas in the domestic as well as industrial purpose, as well to power generation. So India is having excellent waste generated per kg per person per day. India is on the very high side, 105.9%. We can definitely use by 2025. This waste can be used, and waste is wealth, because God has not created anything as a waste. Waste to energy is very much possible. If there is a will, there is a way. At this windmill, people say our windmills are shut down, we are not able to export power to the grid. But put your windmill and desalinate water, you can provide drinking water to a couple of villages. This is what is being done in this remotely located wind turbine. And virtual net metering. Net metering is one in most states, the net metering has been now getting avoided. The concept of net metering is if you are producing solar power in your house and if you are exporting to grid, whatever you are using exported to the grid can be reduced from your bill with the same money. But now with the gross metering, what will happen is what you export to the grid will be paid at a rate fixed by the regulatory commission. So what you use in the house will be billed actually like any other customer. How to optimize using solar? That's why I said earlier, you use your high energy consuming machines like grinder, water, washing machine, motors, pumping during daytime when the sun shines there, so that you don't export the energy which you are generating to the grid. Then you will reduce your bill. A virtual power plant, you can think of with a smart computer controlled, digital network controlled grid. You can have wind power, photoelectric, vehicle to power the grid, vehicle to power, battery swap stations, micro turbines, fuel cell, all other things can be used in the location. I think I'm closing on the time, another 6 minutes. I may have to run a little bit faster. There are alternate fuels, fossil fuel, transport imported fuels. There are several types of fuels possible. Ethanol is now allowed in to be blended, and biofuel, if you use the, you can reduce the carbon emission significantly by blending ethanol. First generation is from oil crops and palm rapeseed oil. This is called first generation biofuel, ethanol to diesel. Second generation uses crop residues and wood residues and waste. This is second generation. Third generation will be microalgae and also that will become diesel. That will be third generation biofuels. This in India is a biofuel driven car in Nagpur. Tesla showroom in Berlin, which I visited. Everybody is allowed to feel the car. You cannot drive the car. One charge you can almost 400 kilometers in one charge. And this top also you can load your luggage, and the bottom behind also you can load your luggage. And, e-vehicles are very common in UK and Sweden especially. When you are working in the office, you can charge with renewable power, then it will become cheaper. And charging station establishing in rural areas and urban areas, it is cheaper than establishing a petrol bunk. So for level 1 charging, low level charging, it's 13,000. Level 2 charging for two-wheelers, 3 kilowatt up to 3 kilowatt. It will be about up to say 2 to 3 kilowatt. It's about 3 lakhs. And fast charging, if you want to have 15 lakhs, that's it. So it is cheaper than establishing a petrol bunk. So we need to establish with renewables these charging or battery swapping stations for our future electric vehicles. Railway which you have seen is fully powered, wind powered railway system in Netherlands. Smart grid, all the renewables and other conventional power, and intelligently manage what is the demand and generate the demand. And the fuel cell, the concept is simple. It takes oxygen from atmosphere and hydrogen from a storage and produces energy which can be used, and exhaust is good water. By just adding remineralizing, you can use it for drinking also. So the advantage of fuel cell, the output is not CO2, it is drinking water. You can just remineralize it and make it potable water. So This website will give you a lot of information about fuel cells. And hydrogen energy is another one. These tanks are storing hydrogen. These are not regular water tanks. You can fill in hydrogen in your office premises in a fuel cell car. Toyota has concentrated the hydrogen vehicles as well as DC powered vehicles, and they were being the patent cost. You can charge like petrol, like a conventional car. Within 3 to 5 minutes, you can refuel your car, hydrogen powered car, and they give you the technology to set up hydrogen station free of cost. They were giving free of cost in 2016. Now it may be charging. So refuel and go 550 kilometers. And hydrogen production can be from many sources, from coal, natural gas, biomass, renewable energy, just water cracking with the renewable energy that can also come out with hydrogen. So many processors can give you hydrogen. Only thing is the hydrogen has to be transported properly, and it has to be stored properly and used as a fuel cell car, fuel cell vehicle, or fuel cell hydrogen vehicle. This is an electric car which can be selected by a mobile app, and you select the electric car and keep your mobile on the windscreen. It will open the door. You can take the car from your shopping in your house and leave it in the airport and fly anywhere. That car will be taken by somebody else. No trip is wasted this way, and that too when you use the electric car, it is pollution free. This is in Germany, Berlin. Basically, what we are looking at is the mindset change to use alternative fuel for automobiles. That is required, and it will soon happen, so that we leave a greener world to our grandchildren and children, ensuring sustainability and inclusive development, including job opportunities, earning opportunities, and several local material can be used for these kind of renewable energy systems. This is global energy transition. This is a proposal by report. It's a report which is available. Prepared it. It's a roadmap for renewable energy for 2030 and so on. We have almost from 50 gigawatt of wind. We have gone almost 590 gigawatt. From solar, we have from 15 gigawatt, we have reached almost to the same level. 6 million electric vehicles are plying in the world today. Is going to increase enormously. Why we have to use affordable and renewable energy? We have to concentrate more on that is because in the sustainable development goals, poverty, zero hunger, quality education, everything can be addressed by addressing the important goal, affordable and clean energy for all. We have renewable energy sector, power generation. We have good progress, and of course, solar is going in a big way. Well, wind is slightly back. It has to be pushed up by promises, and electric vehicles are yet to take off in a big way in India. These are other technologies for renewables. And India is in a fast track growth along with China, and 11% growth rate in Indian renewable sector. What you see here, wind and solar, everything, we have the growth rate is quite significant, and the 11% growth rate when compared to other countries. India and China share the same growth rate in the renewable sector. Big markets in the world. Electricity penetration has to be 86% of power should be from renewables, and that means 56% of the energy should be coming from renewables. This is a goal. You have to use public transport, avoid a single person driving a single car. And energy consumption, this gives you final energy consumption. It is called final total energy consumption. It is equivalent tons of carbon it is showing. One important thing is today's scenario, it's not only system and energy system conservation efficiency, it's also economy, and next to economy now society and the earth, mother earth is very important. Environment, energy and environment is important. We are facing it already. Corona has brought down the pollution so much because so much we have been polluting. We have to reduce this further. The installed capacity as predicted by Winter, Tobias Winter, Director, Indo-German Energy Forum, Delhi, in a recent webinar, 26 May, he has predicted the growth of renewables in a big way in future, and the coal is going to come down even with 4% annual growth or 7% annual growth. Our energy demand is going to be very high, and in which the renewable sector is going to be quite big in future. Okay, you can also think of zero energy building. This is in Kilpak, right in the middle of Chennai city. One person has put almost, he's not using any energy from grid. He is not dumping any waste. He has got a biogas plant he uses in the kitchen. He has got a 3 kilowatt solar at 1.8 lakhs, and he is using for the entire power use. And he is using latest addition drinking water from atmospheric humidity at the cost of 40,000 rupees. This also is added in his house. He's called a solar man. If you just Solar Suresh, if you type in the Google, you will get a lot of details about him. His house is in Kilpak, right in the middle of the city, busy city like Chennai. Okay, what we can do to save to the society, future generation. We have enjoyed our CO2 will remain 120 to 150 years, so emit less. Renewables play a vital role in sustainable global energy transition, which is my passion. Shine and heat and cool with solar, wind with wind, onshore, offshore, sea, land breeze can also be used with small wind turbines, which I have showed you. Think small, do and get done by the mass. 18 rupee per unit has come down to 2.41 per unit solar power because of the mass deployment from almost 2 gigawatt to now 32 gigawatt installed capacity in India. That has brought down the cost. Similarly, think of small wind turbines around your home, in the compound wall, on the roof. You can definitely do better. Inform renewable energy can be, with smart grids, we can manage further. You remember recently, Modi ji's 5 minutes was well managed. Everybody down and shut off. All this kind of power fluctuation can be very well managed by intelligent and smart grids. God has created no way. So let us use waste as wealth. Future of sustainable mobility is Internet of Things, that is Internet and communication technology, industrial Internet of Things, and so on, is going to facilitate digital control of electricity and energy system in the world. They are already talking of prepaid electricity in the new electricity policy. We are only the generation which can save the future mankind, Mother Earth, by following sustainable global energy transition methodologies. Thank you for the opportunity.
Thank you, sir, for an enlightening session on various sustainable energy sources. There are few questions from the audience. So the first question goes like this: how does pandemic emergency like coronavirus outbreak affects the sustainability? Whether this outbreak is boon or bane to environment?
In my view, it is a boon because when the lockdown is off, if you want to maintain the same kind of a low level of pollution in the atmosphere, if a big push is given to the renewables, it is going to be a boon because You can educate solar panel installation in just 3-4 days to any layman in the village. And he can have a living by installing solar panels and maintaining them. So like solar, wind, it is going to be a boon. Renewables, sustainable development, the use of energy is going to be a boon, and it is going to be local and inclusive social development with a lot of employment generation, in my view. Yes.
Okay. Second question is, what is the difference between on-grid and off-grid?
Yeah, on-grid, you will not have to invest on battery, which needs to be replaced every time, right? If it is off-grid, if you want to power, you need the light only in the night. So you cannot have the light in the night if the sun is not shining, if it is solar. Only you should have a windmill separate, but wind should be there. So off-grid is where a battery back or a windmill or a diesel genset along with the renewable energy source is called off-grid. On-grid is grid tied. You don't need a battery storage. But if the grid is shut down, your generation will also go. You cannot have power in the house. Yeah.
The third question is, why can't we utilize the velocity of wind at the time of cyclone if we can design a wind turbine according to the situation properly?
It is practically not possible because such high wind speeds will not allow the aerofoil behavior. You know, the aerofoil is one in which the air will touch on both surfaces smoothly if it is the aerofoil. If the aerofoil is tilted, it will get separated on top surface or bottom surface. There will be a differential pressure. So unless there is a steam flow, a steady flow, continuous change of direction, you cannot capture energy. Cyclone, as you know, the change of direction will be instantaneous every second. So windmills, no windmill in the earth today can operate beyond 25 meters per second wind, that is 100 kilometers per hour wind. So if you design a windmill aerofoil or windmill wind turbine which will run beyond 25-30 meters per second, you will get a Nobel Prize. That is the status of this.
The last question is there any way to reduce the wastage of water in hydropower plants?
Normally, hydropower plants are designed with a multi-purpose. They have flood control and irrigation and everything. And whatever water is used for power generation is being sent to either irrigation, and it can also be pumped back if there is a geometric level difference between dam and the penstock. Then you can pump back the excess water if you have excess power from renewables and use it as a pumped storage tank, so that if there is a sudden stoppage of wind or a cloud over a big solar plant, then you can use the hydro generation. Unlike thermal, idle power plants can generate power instantaneously as a switch on, whereas thermal requires warming up. So by pumped storage, you can use wastage of water. Normally, wastage of water is minimum in hydro plants because it is being used for irrigation, multi-purpose. Yes.
Okay, thank you, sir. Now we have come to the end of the session. It's my privilege to propose vote of thanks on this occasion. Firstly, I would like to express my heartfelt thanks to Dr. S. GOMATHINAYAGAM for accepting our invitation and enriching our knowledge on sustainable energy. Thank you, sir.
Thank you.
I extend my gratitude to management and principal of VVCE for their continuous support in conducting this event. And also, I would like to express my gratitude to our beloved HOD, Dr. H.S. Dayananda, for his support. Thank you, sir. And I also extend my thanks to my colleagues for their unconditional support in organizing this event. Finally, I express my gratitude to all the participants for their active participation in the webinar. Thank you, one and all.
Thank you, Dr. Umesha.
Thank you.
You forgot to mention that we were contemporaries in IIT Madras.
Yeah, okay. Correct.
When he did MTech, I did MS at that
MS,
time.
yeah, yeah.
My research. Yeah. Thank you very much.
And also, he's my colleague in SCRC for 25 years. Okay.
25 years. Yeah.
And we also got a lot of awards that also I have not mentioned. I think, okay.
Yeah. Thank you very much, Dr. Misha and Dr. Dayananda, and thank you, VVCE, for hosting this webinar in a lockdown scenario. Thank you very much.
Thank you, Dr. Gomathinayagam. It's a very informative and interesting.
Thank you.
I think all our participants are enjoyed your session.
Thank you very much. Thank you.
Thank you. Bye.
Yeah, thank you.
Thank you, sir.
Thank you. Shall I close? Thank you.
Yes, sir.
Thank you.
ಇನ್ನೂ ಇದಾರಲ್ಲಪ್ಪ 140.
Hello? Have I closed?